everyone, in today's lesson we're going to continue with use substitution. This time we're going to include problems that involve ln and e. So let's take a look at example number 1. I want to integrate this function. There's really nothing that I can do as far as using the power rule is concerned. I can't double distribute, I can't divide, so we need to think of another way. So what we're going to do in this case, it's a little different than the last video. We're going to let the denominator equal u. So the first day we did u substitution, it was rather easy to figure out what u was because u was in the parentheses. So when you have a fraction, you want to let u, so when you have a fraction without parentheses, you need to let u equal the stuff that's in the denominator. So let u equal the denominator. So let's do that. So we're going to let u equal 5x to the fourth minus 2. And then just like we did for u substitution the first day, our second step is going to be to find du. So let's take the derivative of both sides. So the derivative of u is du. The derivative of 5x to the fourth is 20x to the third. The derivative of a constant is 0. And we have to put dx because we're taking the derivative with respect to x. Then just like we did in the previous video, we're going to solve for dx. So we're going to divide both sides by 20x to the third. And we're going to get that dx equals du over 20x to the third. So now we can go ahead and put our information into our integral. So we have the integral. Since they have this negative on the outside here, I'm just going to put it with the numerator. So I'm going to say negative 60x to the third over u, because I let u equal the stuff that was on the bottom. And I'm going to replace dx with what it's equal to. So du over 20x to the third. So if you want to step for step 4, plug in u and dx. And then step 5 will be to simplify and integrate. So what can we simplify? Well, I see that x to the third and x to the third can cancel. I also see that I have negative 60 divided by 20, which is negative 3. So I really have the integral of negative 3 over u du. So now my integral is all in terms of u. So that should make this a little bit easier for us to integrate. So I know that when I have 1 over a variable, that it's ln. So the first thing I want to do is take this negative 3 and bring it on the outside. So negative 3. And then if I'm taking the negative 3 out, it's simply 1 over u du. And I know the integral of 1 over u du is ln of the absolute value of x. So ln of the absolute value of u in this case, and then plus c. And then don't forget to bring down the negative 3 in front. Now, technically, you're doing negative 3 times both of these things, but negative 3 times a constant is just going to be another constant. So we can just bring it to the first term, and that's fine. And then my last and final step is to put x back in. So in the very beginning, we let u equal this 5x to the fourth minus 2. So I'm just going to replace that for my final answer. So we have negative 3 ln of the absolute value of 5x to the fourth minus 2, and then plus c. So that is my final answer. All right, let's try another example. Okay, this time we have e. So e is a little bit easier to find what we're going to let u equal. So step 1, we're going to let u equal the exponent of e to some power. So whatever the exponent is, that's what we're going to let u equal. So 4x to the fourth minus 3 is my u. So let u equal 4x to the fourth minus 3. And then as we usually do, we're going to find the derivative of both sides and then solve for dx. So du, take the derivative of 4x to the fourth is 16x to the third. The derivative of negative 3 is 0. And then we have a dx because we're taking the derivative with respect to x. And since this is attached by multiplication, we can simply divide it out. So we have dx is equal to du over 16x to the third. Step 4, same as before, we're going to put our values into our integral. We're going to put in u and dx, and then we're going to integrate. So we're letting u be the exponent. So we're integrating 16x to the third times e to the u, and the dx is du over 16x to the third. So du over 16x to the third. And what we see, we need to simplify now. So the x to the thirds, so maybe I'll make that a step 5. Simplify and integrate. So maybe we don't integrate there. So just put in u and dx, then we'll simplify and integrate. So the 16x to the thirds actually cancel, which is nice. So we have the integral of e to the u du. And if you remember, the derivative of e to the u is just e to the u. So this one is simply e to the u plus c. And last but not least, my final step is put the x's back in. So what did we let u equal? Well, 4x to the fourth minus 3. So my final answer is e to the 4x to the fourth minus 3, and then plus c. That is my final answer. All right, I'd like you guys to go to the next page here, and I'd like you to try these two for homework. We'll call this our concept check. So I'd like you to try both of these on your own for homework, and I'll start class this way tomorrow. And if you have any questions along the way, jot them down, and don't forget to ask me in class tomorrow. All right, have a good night.